surface tension is force per length. You multiply length on both sides, the tau becomes work, which has the dimension of energy. What will you get if you have length times length? Area, good. So you get this is area, and the tau is work, which is energy. So indeed, the dimension of surface tension is energy per area. Now, nature has a tendency to decrease their potential energy. When this ball is released, it will go down because it wants to lower its gravitational potential energy. The reason that this water bottle cannot stay like this is because it has a chance to decrease its potential energy. Nature wants to have as small potential energy as possible if you're not fixing their position. This is why the bubble looks spherical. When you look at a bubble, it has an area. So its internal potential energy will be the surface tension times its area. And bubble will want to decrease this potential energy. Surface tension is fixed as long as you are using water and air. So the only thing it can do is to decrease its area as small as possible. But it cannot just shrink into a small ball because there's air inside. So you need to maintain the volume. The volume of a ball is, you don't need to know this. This is like 4.3 pi r squared r cubed. And its area will be 4 pi r squared. I am actually not sure. Let me Google the formula of volume of a sphere. This is how you do physics. When you need something mathematical, you just Google it. Yeah, 4/3. Good, I'm not wrong. So the reason that the bubble wants to be a sphere is because that's the smallest area you can get by having its volume. Let's just compare it with another example. Let's ask this question. Why don't a bubble want to be a cube? A cube has area. If this length is L, and area is L squared. But how many surfaces does a cube have? 6, good. 1, 2, 3, 4, 5, 6. Yeah, it's 6. Okay? And the volume of the cube is L cubed, good. So when a bubble wants to be a bubble, doing its bubble thing, it has different choices of what shape to be. One is sphere, one is cube. There are other shapes, but this is easier. So why does a bubble choose to be a sphere, not the cube? When it is a bubble, the volume is fixed because there's air in there. The bubble cannot just shrink, and the air inside of it will make sure the volume of the bubble is that big. So if you want to be a ball, its volume being a ball must equal its volume of being a cube. Okay? So if it chooses to be a ball, its area, its volume will be 4/3 pi r cubed. And if if it chooses to be a cube, its volume will be length cube. So between a cube and a sphere, if it chooses to be a cube, then the length of that cube should be the cube root of this whole thing, which is there's 4 pi over 3. Root cube of r is just r, so if this bubble decided to become a cube, the length of that cube will be the area of the sphere times this number. Okay? So how big will the area become? The area of a cube, which is 6 times L squared, will be 6 L squared, so you need to square this ugly thing times r squared. And you need to compare that with the area of the bubble when it is a sphere, which is 4 pi r squared. So we want to compare which number is bigger, 4 pi or this ugly thing. If you have a alright, I do the hard one, you do the easy one, and then you guys tell me how big is 4 pi in terms of like decimal numbers. I am going to calculate 4 pi. 4 times 5 divided by 3 squared. So the number up here is about 15.6. How big is 4 pi?
4.57.
What?
4 pi is about 12.57.
So let's keep it at 12.6. So you see the sphere will have a smaller area than a cube under the same volume. So this is why a bubble decided to be a sphere. This is the smallest area it can get with a fixed volume, and because its potential energy is proportional to its area. So to lower its potential energy, it will become a sphere. Okay? Any question?
Because the potential energy is proportional to area.
Yes. The surface tension is actually a area energy density. So the bigger the area, the bigger the energy. Bubble want to, or everything in nature will want to lower their potential energy. So that's why bubble is spherical. You can make it kind of wiggle a little bit, but it will always try to go back to the sphere. And if you look at a water bubble on a table, it's not a perfect sphere but kind of squeezed, because you also need to consider the gravitational potential energy. For a water bubble on a table, you want to decrease the sum of surface energy and the gravitational potential energy. So that's why it's not a perfect sphere. But for a bubble, the air is very light, the gravitational potential energy is negligible, you get a perfect sphere. Okay? So I will give you one homework for that hairdryer and one for bubble. You just need to explain why bubble is spherical in terms of energy. Okay? Alright, that's it for today's lecture. I will stay around if you have questions.